Let's do a quick review here of some elements of trigonometric functions. First of all, I want to talk about radians versus degrees. 99% of everything that we're going to be doing in this class is going to be in radians. Every now and then, degrees will pop up. I know most of us think much better in degrees. You've kind of grew up with it, but radians in a lot of ways actually makes a lot more sense. Now, radians, the radian measure is really nothing more than the length of the arc associated with theta, given or assuming that the radius equals 1. So if I start off in the standard position at 0 degrees and I come up here at what we think of as 45 degrees, here's theta. Let's just say I'm at 45 degrees here. Now if this radius r equals 1, which means this is also equal to 1, I'm not drawing this real well, but anyway, if this is 45 degrees, then the radians is actually pi over 4. Pi over 4 is the total length of this arc. So what's nice about radians is actually associates arc length with it. Degrees doesn't do that. Now a full circle if I go all the way around with a radius of 1, that has a length of 2 pi. When I say length, I'm talking about the measurement of the circumference here, because the arc length is all the way around. Now, degrees, as I'm sure you recall, there's 360 degrees in a circle. Now, why 360 degrees? You know, I don't know. Actually, I've gone to several talks and I've heard mathematical historians talking about this sort of a thing, and they debate why there's actually 360 degrees. So honestly, I can't tell you why specifically there's 360 degrees in a circle, where that came from. There's all kinds of stuff about back whenever they thought there was 360 days it took to go around the sun, hence 360 degrees. I'm not sure if that's just urban legend or if there's actually some fact to it. But anyway, 360 degrees or in a circle sounds rather arbitrary. But like again, I said earlier that we will almost be working in radians. Every now and then we'll pop in degrees, but you really need to understand radians. Now, we can easily convert back and forth. So let's just do a quick conversion here. Let's convert 30 degrees to radians. And again, this is just a quick refresher. Okay, so I'm going to have 30 degrees. And I want to multiply this by 1. And the one I'm going to pick is pi radians divided by 180 degrees. Because pi is the same as 180 degrees. So this is multiplying by 1, different units, but it's still 1. Well, the degrees are canceled out. That leaves me my units of radians. So this is just going to be equal to pi, and we don't typically even bother writing radians, we understand. 30 divided by 180. See, I lost my degree units. Now I'm in radians. And then when I reduce this, this is nothing more than pi over 6. So pi over 6 is the same as 30 degrees. Now if I started with pi over 6 and I wanted to multiply, or I wanted to get this into degrees, I would still multiply by 1, only this time I multiply it by 180 degrees over pi radians. Well, my radians go away, and then what I end up with is reducing this, and now I have units of degrees. and when I do, this is going to be 30 degrees. So that's a real quick review on going back and forth between radians and degrees. Now, positive versus negative angles. Okay, if I start out the standard position here at 0 degrees, and I have my x and y axes set up, if I take an angle and I sweep it out in this direction, so here's my angle, say it's theta. Theta is positive here. This is a positive angle. This positive angle is counterclockwise. Now, if I swap it out in the opposite direction, if I went this way, now let's just call this phi, this is a negative angle. In this case, phi would actually be negative. So up here, I have theta greater than 0, and down here, I have phi being negative less than 0.